Solve the following initial value problem. So we have a linear ODE, linear differential equation, and an initial condition. So we need to put this into standard form, which is already in the standard form, and we compare with this, find the integrating factor in this way, and we multiply both sides by the integrating factor. Okay, so negative sine x is the px if we compare this with the standard form. Then integrating factor in this case, mu x is e raised to integral of px, which is negative sine x. That is e raised to, negative can be pulled outside, and antiderivative of sine is negative cosine. Negative of negative cosine is just cosine x. Okay. Now we multiply both sides by the integrating factor. Then we get the left hand side is derivative of the dependent variable y, and integrating factor is equal to, right hand side is now 2 sine x. We multiply by e raised to cosine x. Next we integrate both sides with respect to x. Then we get y times e raised to cosine x is equal to, now we need to integrate this function where 2 sine x times e raised to cosine x, so obviously a product, and we know the derivative of cosine is negative sine, so we can use the u substitution. So for that, let's make some adjustment. Let's pull 2 outside. So let's write e raised to cosine x first, and this will be if we think cosine x is u, then derivative of cosine x is negative sine x dx. Okay, so sine x dx is here, negative is missing. So to counter this negative one, so we multiply by another negative outside. So this is in fact e raised to u du. Let's look at here, and we know e raised to u du is just e raised to u. So e raised to u, and derivative of cosine is negative sine x dx. That's du part. Okay, only the negative sign was missing, negative 1, and we multiply by another negative 1. Then we get y times e raised to cosine x is equal to negative 2. Antiderivative of eu du is just eu, e cosine x plus c. Now we divide by e raised to cosine x to isolate y. So y equals, divide both right hand side by e raised to cosine x, so it's cancelled, so negative 2 plus c divided by e raised to cosine x, which is same as e raised to negative cosine x. Okay, now we need to determine the value of c using the initial condition given here. Okay, IC, initial condition. So let me erase this. Then let's go over here. Using the initial condition, y at pi over 2 equals 1, we get y is 1 when x is pi over 2. So y is 1 equals negative 2 plus x is pi over 2. So c e raised to negative cosine pi over 2. Cosine pi over 2 is 0, so negative 0 is just 0, and e raised to 0 is 1. Now move negative 2 to the left, that means add 2, so 1 plus 2 3 equals c, or c equals 3. Thus the final answer is y equals negative 2 plus c is 3, e raised to negative cosine x. Final.